I think I'm live. Let me just check. I'm live or not. Yes, I am. Okay. Let me just start by reading the problem statement. Okay, I think I'm visible, right? Okay. Given an array of distinct positive integers, your task is to find the largest subset such that for every pair of elements x comma y in the subset, either x divides y or y divides x. If multiple subsets of length exist. Okay, so what is the expected time complexity? O of n square, and the space complexity is O of n. That is, we can use nested loops, right? Okay, let's start with some examples. If the example is 116 7 4, okay, what if we make use of or mm, yeah, we can do something like every pair of elements now, every single pair of elements, right? So yeah, suppose if this is the case, 1 4 8 1 4 8 and 16, this is our answer. So if this is our answer, what can be the case? It's like okay, if we are going to use nested loops, suppose, because accepted time complexity is of n square, we'll just sort the array. Okay, the first thing we'll do is we'll just sort the array. So it is going to be n square log n, right? No, or n square is greater. Okay, we'll just sort the array. After that, we'll check one for two, like for one, starting from one. Okay, 2 is divisible, 3 is also divisible, 4 is also divisible, 5 is also divisible, 6 is also divisible, 8 is also divisible, 10 is also divisible, 20 is also divisible, 24 is also divisible, 40 is also divisible, 60 is also divisible. Okay, from 2 only 2 uh, 2 from 2 4 is divisible. Hmm. Every number should be divisible to one another. Okay, that's the main question. If we are going to use something like maximum heat, will it going to work? No. Suppose there is something like 8 4 the 32, 16 2 the 32, 8 6 the 48, 16 48. Yeah, 16 3 the 48. Okay. Okay. If we are taking any one of the uh, if we are taking any one of the array, right? Suppose the array is 116 7 sorted 148 7 16 or 147 8 16. Suppose the array is 2 6 7 8 4. Let me just write my example here. If the array is 2 6 7 8 4 12, 36, 636, 7, 42, 48, and one more thing is one more element 54 suppose. And the what are the possible answers? 2, 6, 12, 36, 42, 48, and 54. This is one possible answer. Second possible answer is 2, 4, 8. If I'll write 12 also, 8, 12. So 12 is not going to be our answer because 8 and 12 are not divisible to one another. Okay, it is telling you every single pair is divisible to one another. Okay, 8, 12 is not divisible. 36 is divisible by this. Okay, no, 32 is divisible. 36 also not divisible. 48 is divisible. Okay, so the maximum that we got is this, right? So how we can do? Hmm, how we can do this? Uh, take the very first element. Okay, one or two, like run two loops starting from, suppose every single element is the starting of this divisible subset. Okay, sort the array. First of all, the first thing that we are going to do is sorting the array. Okay, this is what we are going to do, and let's not jump into the coding part right now. Let me just think of what should be the approach to solve this question. The largest divisible subset is 248, where each element divides next one. Okay, the subset is already the lexicographically greatest one, right? There's 248 where each element divides the next one. Okay, 1 second. Let me just do this. Okay. Starting from the element 1. 1 divides 4. Okay. 1 divides, I found 4. Okay. After that, what? Last element is 4. I have to check a element. I'll get an element. I'll get 4. I'll 4. Okay. And I'll check, is there any element divisible by 4? Same I'll do with 6, same I'll do with 7, same I'll do with 8, same I'll do with 4, like any other element. Okay, and at the last, I'll just keep a maximum of all those things. Let me just code this solution out. What are things that we should need? The first one is okay. Also, which is the largest subset? The main thing. Okay. Okay. What is the largest divisible subset? Where each element divides the next one. This subset is already the lexicographically greatest one. Can we just first of all get that? Let's think of getting the answer first of all. And see what is our idea for int I is equal for index is equal to 0. idx is smaller than n, idx plus plus. Okay, now what I have to do, let's keep it here. Int element is equal to a double r of idx. Okay, now check for every single element for int index I plus 1 to plus 1 to index is smaller than n, index plus plus. Okay. What I have to do, if array of index element is equal to 0, if it is divisible by this, just update my element to uh, just update my element to what, update my element to uh, the array of index. Okay. And uh, temp dot push back the element. Okay, great. I can do this thing. One more thing, the I have to find the maximum, right? So I have to keep track of length of this. So length plus plus, great. And here I'll check if length is greater than, or length is greater than the previous maximum, update the value of length. Length is previous maximum is equal to uh, updated length, or length. Okay. One more edge case. I think I'm just leaving. Let me just write it here, so I won't forget it. Lexicographically smaller. I'm writing it here so that I won't forget this edge case. Okay, I'm just writing a writing a code which is going to work for some cases. Okay, I'm not writing the full code. Okay, so for index, okay, what are the elements? I have to make a vector of int temp, and temp dot push back element. Okay, why I'm doing this, I'll explain it later on. Also, I have to keep a length, and at the end of this loop, just do length is equal to 0, or you can just keep int length is equal to 0. Great. And in the previous maximum is equal to n. See, the length is not going to be the not going to be greater than, length should be minimum 1, right? So why to keep int min? Okay, great. Previous maximum is equal to 0 for int I index is equal to I smaller than 0, I plus plus int length is equal to 0, element is equal to array of index, vector int temp dot push back the first element. For int I plus 1, index is smaller than n, index plus plus. If array of index mod element is equal to 0, if it is divisible by this, element is equal to array of index. Great. Temp dot push back element length plus plus. Now, if length is greater than the previous maximum is equal to length. Also, answer is equal to temp. Simple. I can do this in C++, right? I forgot. Okay, vector int answer. Great. And now what? I just have to return. Let me just see if everything is working fine or not. Okay, I have to just comment this part out. Okay, expected output 136, 1236. your output 1 to 6. So what's the difference between these two? 136, 126. Huh? Okay, if you are saying it should be something like this, but why 136 is similar? Yeah. Hmm. uh, if array of index element, okay, your output 126 136 136 should be there. Started from 1. It is working fine or not? Okay, element was 1, this was 2. Great. Where is Vipati? The value of element was 1. Okay, it should run for each and every element. This element should be 1. 1 and 2 only. What is the value of how it is? 020306. Value of idx was. Acha, I'm updating the value of element, right? Okay, sorry. Yeah. So the value of element was 1, then it was 2 3, then it was 2 6. So I just added it to our answer. Now again, element, the value of element is array of index. Great. It checked for this one, right? But what, how it doesn't check for 136, right? It doesn't check for 136. It does checked for 126, but it doesn't checked for, it didn't checked for 136. Okay, great. Let me just think, what can I do? Don't have to do much, you just have to keep track of all the elements which is built, right? So what if the element was simple 126 and 136? Okay. uh, from 1, I how can I do for each and every element? That's the main thing now. How can do this for each and every element? This problem is something same like longest increasing subsequence, right? Uh, I have sorted the array, okay, to like check the divisibility in one direction. Okay, what I can do is rather than this step, this was the brute force approach. I can do is I can just initialize DP and previous index arrays, okay, in which I just keep track of all the elements of largest divisible subset ending at nums of I. I'll iterate through each pair of elements, use nested loops. For each I'll just check all the previous elements, okay. If they are divisible, it means that nums of I can be added to the end of the substring or subset. Great. Let me just code this idea of DP. Okay. Uh, okay. What is I'm going to do? I'll just initial n is equal to nums dot size. Okay, and I'll also initialize a d sort nums or 8 dot begin. Blur, okay. What I'll do, I'll initialize to vector of n dp of n comma minus 1 comma previous of n comma minus 1. Okay, I initialize two arrays with n comma minus 1, n comma minus 1. Also, I'll keep track of the maximum idx, which is equal to minus 1, and I'll iterate through all the and index is equal to 1 to index is smaller than n index plus plus. Also, I'll keep track of all the to keep track of the like it is divisible or not. I'll also initial idx is smaller than n idx plus plus. Now what I'm going to do, I'll just in place of n I'll write I, and if it is divisible, a double idx mod a double r of index. If I and index and idx is equal to 0, index and if it is equal to 0, I'm keeping a dp array, right, to make to keep track of all the elements. So dp of index should be smaller than dp of idx plus 1. If this is the case, uh, I will just I'll just write update the dp of I is equal dp of index is equal to dp of idx plus 1. That's it. And also I'll previous of idx to the idx. Yeah. ठीक है. Also, one more thing to initialize the maximum index at which index it is. So, if uh, dp of index is greater than the maximum index, update the maximum index to dp of index. Iterated from the last element to the first element, right? So I just while maximum idx is smaller than or equal to or greater than equal to 0, greater than equal to 0, what I have to do, I have to answer dot push back uh, a double r of maximum index. Okay, after that maximum index is nothing but previous of maximum index. That's it. That's it. Keep updating it, and at the last I got a result or got a answer which is like from the like it is the reverse of our answer, right? So we are going to reverse a answer dot begin comma answer dot end. Okay, and just the answer. Okay, there is some IDX. I was not declared. Where is I? IDX is smaller than index. One more. I was there. Huh? Answer dot begin. Answer dot and Bhagwan. Make me so silly mistakes. Maximum for me it's while maximum index is greater than equal to 0. Okay, 136 output differences. What is the output difference here, bro? Acha, I'm not getting any output. Acha, answer dot pushback. Acha, I'm not I am pushbacking, bro. Where is the array? Just check where is the error. Oh my gosh. The DP should be right. Ah, TP of index should be smaller than TP of IDX plus 1 also. I just have to keep it as fun. Hmm. Index, right. Same 126. It is also giving me 126, bro. Just check where is the error coming. Value of dp of index is greater than maximum index. Maximum index is equal to dp of index, right? It should work. Why this is not working, bro? Can I just remove this? It is coming 126. Custom input 1236. Let's take another input 148716. What is going to be my output? It is working fine for this case, but why not for that case? Because this is lexicographically smaller. My code output is 12630. I don't know why it is not working, because this is lexicographically smaller than that element. So this should work. I don't know, because this is lexicographically smaller than that element. Let me just check why this is not working. What is the correct solution of this problem statement? क्या टाइप कर रहे हो?